What is S? Notice that we are not looking for f of 13, but we are rather looking for S. So we need to form an equation so that s squared plus 2s minus 2 equals 13. When we solve this equation, we find S. Let's collect like terms together and make this a standard quadratic equation so that s squared plus 2s minus 15 equals 0. What are two numbers we can multiply to get minus 15 and add to get plus 2? 1 and 15, no. 3 and 5, yes. We open two brackets. Note here, so we are using this method because the coefficient of s squared is 1. 5 times 3 is 15, but what we are looking for is minus 15, so one of them must be negative. What we decide this will be the coefficient of s. In this case, 5 minus 3 is 2. So s plus 5 and s minus 3. Then finally, s equals minus 5 or 3. In s equals minus 5 or 3, we finally then decide if s is 3, they are equal. If s is minus 5, b is greater, but we have conflicting answers. So our correct option is D. In this question, we are looking for the value of s, given that the range is 9. Oh, it's not that question. So we are solving 0.99 raised to the power 98. So if you multiply any number between 0 and 1, it will be less than the number, like 0.9 times 0.9 is 0.81. So 0.99 raised to the power 99, we reduce. It will surely be less than 1. For number 6, if the range of set S is 9 and S is the set of 2, 4, 5, 7, 8, 9, and S can be 11, so that 9 minus 2 equals 9. Remember that range is the highest minus the lowest. Or S can be 0, so that 9 minus 0 equals 9. If S is 11, the median is 7. That is when we arrange in ascending order. If S is 9, the median is 5. So 5 and 7 are two possible answers. The next question looks so easy. Of course, supposed to be easy. Notice that we have 3 brackets, and between these brackets is just a plus sign, meaning now we can remove all the brackets. Nothing will change. If it was minus, we will have been careful because the sign of the inside bracket will have changed. Now that it's plus, nothing is going to change. The next thing is to find the LCM of the denominator, which is 40. We are going to change everything, each time making the denominator 40. Why did we have 5 over 40? So you can notice that 5 over 40 is the same thing as 1 over 8. 5 times 8 is 40. Then 5 times 1 is 5. We are going to do this, the same thing for all of them. 12 over 40 is 3 over 10. 4 over 40 is 1 over 4. We do this for all of them. After that, we add the numerator together. Remember that the way we are rewriting it means all the denominators will be the same. So we repeat the denominator, then add the numerators. Twenty-five over 40 is 5 over 8. Of course, 20 over 40 is half. But this is not plus, it's supposed to be minus, because we are taking all the original signs. Now let's add the numerator together. 5 minus 12 plus 10 minus 8 plus 25 minus 20. Can you confirm that it is 0? 0 divided by 40 is 0. So the answer to this is 0. We move to the next thing. In this question, we are given the side of a square. But let's know what we are looking for. What we are looking for is the area of the circle minus area of the square. That will give us the area of the shaded. Each of the side of the square is root 2. Area of square is side times side, which is root 2 times root 2. So that is easy for us to get. Remember what we are looking for: area of the circle minus area of the square. And we also know that the diagonal of this square is the same thing as the diameter. It's the same thing as the diameter of the circle. So the first thing is to find the area of the square, given that the side is root 2. So what is the area? Area of a square. Don't forget that a square is also the same thing, is also a rectangle. Base times height, length times width, length times breadth, anyone. So the area is root 2 times root 2, which is 2. The next is to use this to find the length of the diagonal. And the length of the diagonal is the same thing as the diameter. And half of the diameter is the radius. Half of the diameter is the radius. To do this, we are going to take advantage of 45, 45, 90. And the ratio is 1, 1, root 2. Here, one of the side is root 2. So root 2, then root 2 times root 2, which is 2. Meaning that the diagonal of this is also root 2. No, the diagonal is 2, because If we do 45, 45, 90, root 2 times root 2, 1, 1, root 2 times root 2 is 2. So the diagonal of this this square is root 2. You can see here that the diagonal and the diameter are the same. Remember, the diagonal is simply the longest line, the distance between the longest parts in a geometric shape. And the geometric shape of interest here is the square. Once we know the diameter, that the diameter is the diagonal, we divide the answer by 2. So the diameter is 2. The diameter is 2, and the radius. The diameter is 2. How about the radius? The radius is half of the diameter. If we know the radius, what else? We find the area of the circle. The area of the circle is pi r squared. That is pi times 1 squared. So the area of the circle is pi. Area of the shaded is area of the circle minus area of the square, which is pi minus 2. This is another shaded figure. Generally, how to find areas of shaded figures is to add them up, find the areas of the known, subtract the knowns, and have the remaining is unknown. But this one too, area of the shaded, the actual shaded, which is BCA, we can easily solve it by saying half base times height, and the base is 7, not 2. So 7 times 6, 42 divided by 2, 21. But let's go through the long way. Let's go the longer route, which is looking for the area of the full triangle minus area of the triangle that is known. Area of the full triangle will be 9 times 6 divided by 2. 9 times 6 divided by 2. What is 9 times 6? 9 times 6 is 54. Divided by 2 is 27. Then area of triangle ACD is 6 times 2 divided by 2. 6 times 2 is 12. 6 times 2 is 12. Divided by 2 is 6. So area of the shaded will be 27 minus 6, which is 21. Remember, we can also solve the area of the shaded alone. Which is to say half times 7 times 6. That is correct too. Okay, so this will have been more straightforward. For solving it, composite, knowing how to solve area of composite generally too is helpful. The next question. All right, for this question, if Clarissa's monthly mortgage payment is less than 1/3, what does that mean? Less than 1/3, but more than 1/4. So we can find 1/3 of y and 1/4 of y. So 1/3 times y equals 600, and 1/4 of y equals 600 too. So of which y equals 1,800 and y equals 2,400. Remember that this is monthly mortgage. So annually, we have 1,800 times 12 and 2,400 times 12 to get the annual range. This is monthly range. We need the annual range. So the annual range will be 18 times 12, then we add 2 zeros. That should be 21. That'd be 21,000 something. Yes, 18 times 12. Remember that 18 times 10 is 18. Then 18 times 2. That's 18 plus 36. 18 plus 3. Again, 18 plus 3 is 21. Then we add the 600. I mean, if you're not using calculator, but this is a GRE question, so you're allowed to use calculator. Another one, of course, 2,400 times 12. So 21,600, and how do you go about solving 24 times 12? So you can say 24 times 10, then 24 times 2. Yeah, 24 times 12 is 24 times 10, and 24 times 2. Then you add your zeros. 24 times 10 is 24. Okay, so we have these two values. We are looking for values between this. We are looking for values between this. Between 21,600 and 28,800. Any value that is not within this range is the correct answer. For instance, 12,200 is the correct answer. Why? because we are looking for not. The question says not. We are selecting the ones that are not. So we are selecting the ones that are not. So the first one is not, because it's 21,000, almost 21,000 is less. 17,000 is less. 21,000 is less. The first one is 12,000 something. I'm sorry, is less. You see that it's 12,000 something is less. So we are selecting 24,200 is within. So it's wrong because it is correct. It can be. It is wrong because it can be. We are looking for the one that cannot. 29 is too much. That one is too much. The next question is about exponent. 5 times 2 raised to the power 12 divided by 4 raised to the power 5. What comes to mind? 2 raised to the power 12. So we change 4 raised to the power 5 to 2 raised to the power 2. 4 is 2 raised to the power 2. Then we put back our 5. That will now give us 2 raised to the power 10. That will give us 2 raised to the power 10. So that will give us 2 raised to the power 10. 12 minus 10 is 2. So 2 raised to the power 2 is 4. 4 times 5 is 20. We can also see this as, we don't want to do it that way. This can also be for us. It can also be for us. 5 times 2 raised to the power 12. We can change this 2 raised to the power 12 to 4 raised to the power 6. So 4 raised to the power 6 divided by 4 raised to the power 5. So at some point we are going to get 4 raised to the power 6 divided by 4 raised to the power 5. 6 minus 5 is 1. So we have 5 times 4 raised to the power 1, which will give us the sentence as we had before, 20. Okay, now getting ready for the next question. If y is an integer and root 48y is also an integer, which of the following is the lowest possible value of y? We are looking for just the square root. We are looking for a perfect square. It's just to say, what's the lowest number? If you multiply it with 48, it will make it a perfect square. And we do know that we can get a perfect square from prime factorization. If we do a prime factorization of 48, we know the one that is not complete. Think about it this way. The prime factorization of, say, 10 is 5 times 2, 2 times 5, which is the sentence as 5 raised to the power 1 5 raised to the power 1 times 2 raised to the power 1. We are looking for the smallest number to multiply this so that it will become raised to the power an even number. So 2 raised to the power 1 becomes 2 raised to the power 2. 5 raised to the power 1 becomes 5 raised to the power 2. So we are going to multiply by 2 and by 5. And is it not interesting that we are going to multiply by 2 and by 5, which will now be 10 times 10, and 100 is the perfect square. That is all. We can take another example. Let's take another example. Let's say, what other example can we take? Maybe 8. 8 is not a perfect square. The prime factorization of 8 is 2 raised to the power 3. And in that case, we are looking for a way to make 2 raised to the power 3 to become 2 raised to the power 4. You see, we are going to multiply it by 2. 2 raised to the power 4 is 16. 16, the perfect square. Whenever we raise a number to the power of even, it gives us a perfect square. Next, 48 is 2 raised to the power 3 times 6. That is 8 times 6. So 6 is the same thing as 2 times 3. So we have 2 raised to the power 3 times 2 times 3. If we combine all the two together, it will now be 2 raised to the power 4 times 3. 2 is already raised to the power of even. So what is remaining is to raise 3 to the power of even by multiplying it by 1. So we are going to multiply it by 1. That is 3 raised to the power 1, meaning 48 times 3. Notice that 48 times 3 is 144. And the square root of 144 is 12. The square root of 144 is 12. All right. Next question. We can also take the advantage of prime factorization here. Yes. But by the way, what is the question asking? What is the question asking us to do? The question is asking, the question is asking us to find to find which of these numbers can divide to 10. Okay, that is the simple thing it's asking us to do. Yes, we can start checking 210 divided by 6, 210 divided by 12, yeah. But we can also put this put 210 in form of prime factorization. So we can find the prime factorization of 210. So what is the prime factorization of 210? So the prime factorization of 210 is, of course, 21 is 3 times 7. 3 times 7 times 10. That is 3 times 7. times 2 times 5. 3 times 7 times 2 times 5. Okay, 3 times 7 times 2 times 5. All right. So the prime factorization of 210. With that, we can create what we can create number bound. So prime factorization can also be see a way of doing number bound for 210. 2 times 5 times 3 times 7. You see that 6 is 2 times 3. 6 is 2 times 3. That's 14 is 2 times 7. That 5 is 5 times 7. 42 is 6 times 7. We don't have 12. So 12 is not there. Twelve is not there. So we're going to select all except 12. Prime factorization is also a way of solving some other questions, not just about not the simpler type that we solved. Now the next question. This is a triangle and we're looking for W. We know that V and Z not given, but V plus Z plus W equals 180. Y plus S, 180 minus Y, 180 minus Y minus S is V. 180 minus Y minus S is also V, is also Z. You see, Z equals V. Z equals V. Z equals V. Meaning that V plus Z plus W equals 180 already established. Because V equals Z, so two of them together will be 2 times 180 minus S minus Y. Then plus W equals 180. 2 times 180 is 360. 2 times minus S is minus 2S. 2 times minus Y is minus 2Y. Plus W equals 180. Let's collect lifetimes together. W equals 180 180 minus 360 plus 2S plus 2Y. So let's eradicate negative so that instead of starting this with 180 minus 360, which is minus 180, we can write it in a way that the answer starts with positive, a positive number. So W equals 2x plus 2y minus 180. Remember, this minus 180 is because of 180 minus 360. We can also solve this by using number. We can solve this by using number. We can subject V, let's say to 50, Z, let's say to 70, and solve it. So at the end of the day, we check the one that will give us back our W. If that is, if we don't want to go this long route, because this route is also a little more abstract. All right, so thank you. Bye.